Hello everyone, I'm Bharath, and today I'll be presenting my project titled Microwave Oven Embedded Systems Project. This work was part of my 1 month internship at Emertxe, conducted between December 2025 and January 2026. Throughout this internship, I learned how to progress from basic C programming to developing and simulating a fully functional microwave oven system using the PIC16877A microcontroller in MPLAB IDE and PixMLab. So the project overview of this internship is that it allowed me to design and simulate a microwave oven that behaves like a real appliance, supporting multiple cooking modes, timing control, and user interaction. I used MPLAB IDE for development, the XE8 compiler for code execution, and PixMLab to simulate all the hardware connections virtually. So week one uh, actually deals with C programming and mastering C programming fundamentals. So during the first week, my focus was on building a strong foundation in C programming. I revised concepts such as data types, loops, functions, arrays, and pointers. I also created small programs like LED blinking logic and simple menu-driven applications, which helped me get comfortable with structured programming and logical debugging. This week laid the groundwork for my embedded C understanding. So the outcome was to develop a strong understanding of structured programming and logical thinking, and which was very crucial for complex embedded tasks. So, introduction to microcontrollers. So, in this internship, we actually used the PIC16 F877A from the PIC Genius family. In week two, I explored microcontrollers, where we studied the internal structure of this PIC16 microcontroller and its architecture, an 8-bit RISC CPU with 33 I/O pins, timers, ADC, and UART modules. I learned how input and output operations are controlled through registers like port A, uh, port B, port C, port D. This week helped me understand how software interacts with hardware. So basically, the outcome of this week was to gain practical knowledge of hardware-software interaction through registers and input-output mapping. So coming to embedded, coming to week three, which dealt with embedded systems concepts. Week three introduced me to embedded systems design, understanding how microcontrollers, sensors, actuators, and memory units all work together in real time. We analyzed the different categories of embedded systems, such as real time and standalone applications. This is where we began mapping the components for the microwave oven project, deciding which peripherals to use, how the logic would flow, and how the user interface would look. So basically, the design metrics actually include reliability, cost, and power efficiency. And overall, the outcome was to get a comprehensive understanding of embedded system design workflows and performance trade-offs were achieved. So coming to week four, where the main project implementation took place, uh, in the final week, the implementation phase of the project began. The firmware was written in embedded C using MPLAB IDE, and the entire system was simulated using PixMLab on the PicGenius board. I modularized my code into 6 files: main.c, lcd.c, which is basically for the displaying of the LCD panel, keypad.c in order to input all the values from the user side, timer.c, buzzer.c, and mode control.c. And here, mode control.c is typically used for inputting, taking the input of four different types of modes used in this project, and which were start mode, micro mode, convection mode, and uh, grill mode. Uh, s- so simulation environment, uh, yeah, we actually utilize Pixum Lab with the Big Genius board for virtual hardware testing. We developed the code in my MB Lab ID using the X8 compiler, just like I told. And control systems was we configured timer 2 for countdown and interrupt based control, and we integrated the UI with using the keypad and the LCD and feedback buzzer plus fan. So ultimately, the outcome was we successfully created a functional simulation featuring 4 interactive operating modes. So microwave functionality. So as just like I said, there are actually 4 modes. Micro mode is for standard. Micro mode is a standard cooking mode using simulated microwave radiation. User selects micro mode, sets the power level and cooking time, and then the fan starts and the LCD shows countdown updates in real time. So coming to grill mode, it uses heating elements for grilling or browning food. So the user selects the grill mode and sets the cooking time. The fan runs while the timer counts down. Coming to convection mode, it uses the fan and heater together for even heat distribution. So the user sets temperature and time, and the simulation starts after preheating. So the next mode, which is the last mode, is the start mode or the quick start mode. So a default 30-second quick start option is given, and each press adds 30 seconds and starts the fan immediately. So the fan and timer commence immediately upon activation, ideal for rapid reheating tasks. Efficiency and convenience are mainly obtained using the start mode. So several challenges, testings and key learnings were uh, the first one was keypad debouncing, which caused multiple inputs per press and real-time display updates while the timer was running. So this was solved by adding software debouncing in the real keypad function and using timer 2 interrupts to handle countdowns independently. After debugging, the simulation worked flawlessly. The fan and buzzer responded correctly, and the LCD updated per second without flicker. So another error was system. So another key learning was system validation, where we actually verified all 4 modes in Pixum Lab. Buzzer triggers, fan halts post completion slash pause, LCD updates smoothly. These challenges provided invaluable opportunities to apply advanced problem solving techniques in real world embedded context. So now let's actually move on to the code demonstration inside MPLab IDE. So this is MPLab IDE where we wrote and compiled all the code for the microwave oven project. So this project contains multiple .c and .h files, each handling a specific function in the microwave system. So first off, we'll be looking at the main.c file. So the main.c file initializes all components, the LCD, the keypad, the timer, and the input output ports. It contains the main loop that continuously monitors keypad inputs. When a mode is selected, control is passed to the corresponding function in mode control.c. This structure keeps the code modular and organized. So as we can see in this code, initially we tend to include header files like microoven.h, timers.h. Then we actually come down where we actually initialize the void main function, and then we tend to give the code for 4 different types of modes. So the first mode is micro mode, then we have grill mode, then we have convection, and then the start mode. So we also, based on our learning in C in the first week of this internship, we also use if and if else constructs throughout the program. And then we also, in each mode, we tend to have 3 different options like pause, stop, and start. So we also initialize those. And yeah, this is the entire code in the main.c file for each and every single mode. Now uh, moving on to timers.c. So here we in timers.c, the timer to initialization and interrupt routine are responsible for counting down cooking time. This interrupt service routine ensures the timer decreases every second without affecting other operations like display updates. So it's a great example of how interrupts make embedded systems more efficient. And now we'll be taking a look at the lcd.c file and the key matrix keypad.c file. So this is the clcd.c file. Uh, it handles character display like showing the current mode, remaining time, or the done message. So keypad.c handles user input for selecting modes or setting time. So we implemented software debouncing here to avoid multiple triggers from a single press. So as you guys can see, this is the code. So this is for initializing, and then here this is actually for entering characters. This is for entering strings as well as for displaying the output. And now similarly, we're going to be taking a look at keypad.c. So this is the keypad.c file. So we're including the header file directory here. So first we'll be scanning the keypad. We actually use several for loops with this, and in the simulation we actually have two options. So one is an asterisk as well as a hashtag. So the asterisk is actually used for clearing the screen, while whereas the hashtag is used for continuing the process. So now moving on to microoven.c. So this is the .c file which actually encompasses the four different types of modes in a microwave. So first we have micro mode, grill mode, convection, and start mode. Now after this is set, first we'll be initializing the time. Setting the time. So first we tend to set the time. Then, as I said before, we have two options: clear or enter. So the asterisk is for clear, the hashtag is for enter. Then we use an if loop in order to uh, test several cases as to what happens in each case and check as to what happens. Now, after the time is set, we tend to set the temperature in the grill mode. Temperature is entered in degrees Celsius. It's similar to the micro mode. The only difference is the micro mode displays the power, and the grill mode doesn't. It actually inputs the temperature. So these are the three options. Now moving on to micro.h. So this actually includes the list of header file directories which we'll be calling in micro.c and main.c. clcd.h is also used for including the header directories which would be called in clcd.c. So the matrix keypad includes all it includes the code for all the buttons which are present on the microwave and the respective functions each button is supposed to do. And the matrix keypad.h includes the header file directories which can be called in matrix keypad.c. So these modules actually handle the core operations. So All of these modules adjust the timer and fan control depending on the selected mode. Together, these bring the microwaves logic to life. So now I'll be running the code here. So we come here. Yeah, we'll be clicking on clean and build here. So as we can see, you know, it's been cleaned successfully and then it's been built successfully as well. Now, in order to test the simulation, we'll be going to Pixim Lab. So here's the Pixim Lab interface. We are actually using the PicGenius board, which virtually connects components like the PIC16 F877A MCU. It's so it's actually we're using a 16 by 4 cross 4 LCD display. It's a 4/4 keypad, a buzzer. It also includes a fan motor, which is represented. So we'll be starting the simulation now. So first we're going to be using micro mode. So I'll click on one here. So it displays the power as 900 watts initially. So now we're going to be entering the time. So I'll set the time to 20 seconds. So now there are two options. One is clear and one is enter. So if I click on the asterisk, it could actually clear the residual value here. If I click on hashtag, it would actually proceed, uh, for the micro mode operation. So I'll click on hashtag here. So as we can see, the LED turns on. So it also displays the countdown here. We have four modes, just like I explained in the code 4, 5, and 6. So one is start slash resume, pause, and stop. So once this is done, we have time up, enjoy your meal, and then we can choose from the other four modes. Now coming to grill mode, so I click on 2. So I can directly set the time limit which I want to input. So I'll set it to 30 seconds and I'll click enter. So here, if I want to pause, I can click on 5. If I want to resume, I can click on 4. Now, suppose I'm not interested in carrying out the function of any mode. I can just click on 6 and then we can exit back to the main screen. So that's micro mode and grill mode. Now, if I'm coming to convection, here I preheat the temperature and the time. So after preheating, the simulation continues automatically until completion. So if I'm setting the temperature as 5 degrees Celsius, and just to demonstrate the clear option here, if I click on the asterisk, the value gets cleared here. So if I click on 5 and then click on enter, so we have the microwave oven actually preheats for about 60 seconds. Now I can enter the time. So if I give the input as 1 minute, so just like I previously demonstrated, I can just pause. If I want to resume, I can just click on 4. And then if I want to stop the operation, I can just click on 6. And then the fourth mode is actually start. So if I click on 4, so a set time of 30-second countdown begins. So each time I click on 4, and extra 30 seconds would be added. So the LCD updates live and the buzzer alerts when the cycle ends. So to conclude, this project helped me deeply understand embedded systems from low-level C coding to real-time microcontroller simulation. I gained strong experience in MPLAB IDE, Xe8 compilation, and PixMLab debugging. It was a complete learning journey from software fundamentals to working hardware behavior. Thank you to uh, the respective faculty for teaching this entire, for going through this entire internship and helping us. Um, Thank you for watching my presentation and demonstration.